The topic is architecture of Docker, Docker client, Docker host, Docker registry explained. This is the Docker architecture. We can observe that there exists Docker client, Docker host, Docker registry. In Docker client, there exist the commands we run, that is Docker run, Docker build, Docker pull. Docker host consists of Docker daemon, images, containers. Docker registry contains images, plugins. The Docker client. Docker client is the primary interface through which users interact with the Docker system. It is part of Docker's client server architecture and provides the means to issue commands and manage Docker objects like images, containers, and networks. In short, it is the primary way we interact with Docker. When we type a command like docker run or docker build into our terminal, we are using the client. Its job, it acts as the interface. It doesn't actually run containers itself. It just sends your request to the Docker host. Flexibility, that a client can sit on our laptop while communicating with the Docker host running on a completely different server or in the cloud. To understand Docker client, we must know that Docker D or Docker daemon is the main heart of the Docker that functions, and its job is to do the heavy lifting, manage the core Docker functionality. So Docker client helps translating user commands from the CLI or the terminal, or it translates user commands into REST API request and it sends that to the Docker daemon. In short, Docker daemon does all the heavy lifting. It is the heart. It manages the core Docker functionality. However, Docker D cannot translate user request or user commands. It needs Docker client to translate those commands or user commands from the CLI or the terminal that gets the REST API request, which is understood by the Docker daemon. The Docker host. A Docker host is a physical or virtual machine on which Docker engine is installed and running. It is the foundational infrastructure that provides the necessary resources, CPU, memory, storage, and networking for Docker to run and manage containers. In short, it is the machine, physical or virtual, that provides the environment to execute our applications. This is where the magic happens. Docker host provides the environment for core components of the Docker platform to operate. Those core components are Docker daemon or Docker D, operating system kernel, physical resources like RAM, CPU, storage, etc. Docker host uses specific Linux kernel features to provide the necessary isolation and resource management for containers. Docker engine uses namespaces to provide an isolated workspace for each container. That ensures each container has its own view of operating system, including separate process IDs, network interfaces, and mount points. For resource management in containers, it uses C groups, that is control groups, that is used to limit and manage the amount of host resources like CPU and memory that a container can consume. This ensures that fair resource sharing and preventing a single container from overwhelming the system. In short, for resource management, Docker host or containerization or Docker solves the issue that was within the virtual machine or virtualization, where we could be running multiple applications in a single virtual machine. However, there was not a good amount of isolation inside a virtual machine which the containerization or Docker host provides. So this is the features offered by containerization, whereas in virtual machines, if you run multiple applications, each resources would be enmeshed so much that the system may lag or even shut down. However, in containerization, Docker host does the isolation, does the resource management, so that the system doesn't get overwhelmed. How it does? It ensures fair resource sharing. It limits and manages an amount of host resources, CPU and memory that a container can consume, which eventually prevents a single container from overwhelming or affecting the system performance. Docker host so does the networking. That is, the Docker host is responsible for managing container networking. It sets up a virtual bridge network to allow communication between the containers and external networks via host connection. It handles port mapping, which allows services within a container to be accessed from outside the host machine using a specific port on the host IP address. Docker host has the operating system kernel, which means containers running on the Docker host share the host's, that is virtual machine's operating system kernel. That makes the containers lightweight compared to the traditional virtual machines, which requires a full separate guest operating system for each instance. For physical resources, Docker host uses the host machine, that is virtual machines, CPU, RAM, and storage for managing various containers running on it. Docker daemon or Docker D. Docker D listens to the Docker API requests from the client and manages objects like images, container networks, and volumes. Docker D is the background service that runs on host machine and manages all Docker objects such as images, containers, networks, volumes. The Docker client communicates with the daemon to execute the commands. That is, Docker client translates API requests from the CLI or the terminal from the user, so the Docker daemon performs the action. Docker registries. A Docker registry is a centralized storage and distribution system for Docker images. It acts like a digital library for an app store for container images, allowing developers to store and manage and share their containerized applications across different environments. In short, it is a storage and distribution system for our Docker images. If we need a specific environment like Python or Nginx, we usually pull it from a registry. Public registries. Docker Hub is the biggest one. It is a default registry where anyone can find and share images. Private registries. Most companies use private registries like Amazon ECR or Google Container Registry to keep their proprietary code and internal tools secure. Simply, Docker Hub contains images same as GitHub that contains source code. The difference is Docker Hub is used for images and containerization, whereas GitHub is used for application, software development, web development, and source code. Docker Hub contains number of public registries or public images that can be used. We must know that a Docker file contains the instructions and image is the blueprint or the recipe of that instructions in a Docker file. When we run that Docker image, it forms the Docker container, which is like the running instance or the live execution of that image. Docker images are composed of series of read-only layers where each layer represents instructions that are inside a Docker file. Docker images are highly portable and can run consistently on any system, developers, laptops, test servers, etc. that has Docker engine installed, regardless of the underlying infrastructure. Users can store Docker images in the Docker Hub. Docker Hub is the default public registry that offers vast number of libraries of official and community contributed images. We can modify the visibility of Docker image in the Docker registries or in the Docker Hub. We can either make it public for every users to download and utilize and use that Docker image to run a container. However, we can also make that registry or a Docker image in the Docker Hub private, so only you can view and use it. The concept of Docker private registry is to restrict access to only authorized users and systems. A private registry can either be hosted internally on-premise or through a cloud service, AWS, Google, that offers controlled and restricted access to images. Organizations use these private registries for enhanced security, performance, and control over their software supply chain. This ensures that only authorized team members or systems can push or pull images, protecting sensitive or proprietary software components. How they work together. Pull. We tell the client to get an image. Fetch. The host reaches out to the registry and downloads the image. Run. The host turns that image into a running container. So we tell the Docker client to get an image to the terminal or the CLI. That Docker client translates that commands into the API that is understood by the Docker daemon that reaches out to the registry and downloads that image. Later, the host turns that image into a running container. So that is it for the video today. I hope the topic was simple and insightful. Make sure to like, share, and subscribe. Thanks. Have a great day. Bye.